This video is for 7.8 Models Involving Rational Equations. In this video, we will look at Objective 2, Model and Solve Problems with Similar Figures. Model and solve problems with similar figures. Definition: the two figures are similar if their corresponding angle measures are equal and their corresponding sides are in the same ratio. So we say that two figures are similar if one is just a bigger or smaller version of the other. So you can take one triangle. If we keep all the angles the same and keep all the sides in proportion, it'll be the same picture of it, but just a little bit larger. So for example, we have a triangle whose side length MN is 12 and side length MP is 15. The smaller version of it, XY, has an unknown length A and XZ unknown length 10. We can see that triangle XYZ is smaller than triangle MNP. We will use the fact that the corresponding sides are in the same ratio. So if we take the ratio of side length MN to side length XY, that ratio is 12 over A. We need to keep the same order and say that the side length MP to side length XZ is in proportion. Now we solve that proportion by taking the cross products. A times 15 equals 12 times 10. 15A equals 12 times 10, or 120. So we divide both sides by 15 and get A is equal to 120 over 15. Looks like they're both divisible by 5, which gives us 3, and 5 goes into 120. 24 times, and 3 goes into 24, 8. So A is equal to 8, or the length of XY is 8. When you go to a toy store and you see those toy cars in the boxes, they'll usually say down in the corner somewhere 32 to 1 or 1 to 32. That just means that that car is 32 times smaller than the real car out on the street, and all the angles and everything are in proportion. A very classic example we like to do with similar triangles is a tree casts a shadow 25 feet long. So here's my tree, and it casts a shadow 25 feet long. The tree has some unknown height, call it X. So the shadow comes down, the sun comes down and makes a 25-foot shadow. At the same time of day, there's a 6-foot person. And that 6-foot person casts a shadow 2.5 feet long. So we have the triangle formed by the tree, we have the triangle formed by the man or the person. And the tree's shadow is 25 and the tree is X. The person's 2.5 and the height is 6. So the ratios of corresponding sides are equal, or every side is in proportion. So we take the ratio of corresponding sides. X is to 6 as 25 is to 2.5. We solve this by taking the cross products. 6 times 25 equals 2.5 times X. 6 times 25 is 150. We divide both sides by 2.5, and x is equal to 150 divided by 2.5. Let's see, that's 1,500 divided by 25, and 25 goes in 150 6 times. So we get 60 feet. Tree is 60 feet tall. So this concludes the video on 7.8 models involving rational equations, objective 2, model and solve problems with similar figures.